Hi friends, today I'm going to discuss the previous year questions of computer science UGC NET exam. Last class also I have discussed a very few questions and its detailed explanation, so that likewise I'm going this PYQ discussion series. In this class also I have taken a very few questions and it's a detailed explanation. This would definitely help you to clear each and every concept related to each question. Okay, let's move into the class. First question is, which of the statements given below are correct? The midpoint or Bresenham algorithm for rasterizing lines is optimized relative to a DDA algorithm in that option A, it avoids round of operations, it is incremental, it uses only integer arithmetic, all straight lines can be displayed as straight. Actually, in this question is coming from computer graphics. Okay, they are asking the comparison between Bresenham and the DDA algorithm. Okay, first you have a clear idea about Prasanam and DDA algorithm. First, we look into that. What is Prasanam and what is DDA algorithm? Just look into that. Prasanam line algorithm is an efficient and precise raster line generating algorithm. Scan convert lines using only incremental integer calculations that can be adapted to display circles and other curves. In this Prasanam algorithm, actually, they are using mainly used for raster line generating, and also it uses only incremental integer values. Okay, and the major characteristics is it avoids round of operations, it is incremental, and also it uses only integer arithmetic, it avoids the generation of duplicate points, and another it can be implemented using hardware because it does not use multiplication and division. And another one is it is faster compared to DDA because it does not involve floating point calculations like DDA algorithm. That is, these are the characteristics. If we know the characteristics of Bresenham algorithm, we can easily answer the questions. What are the characteristics of Bresenham algorithm? It avoid round of operation. That is, we have already said that it is taking only integer values, that is they are not accepting floating point value. Floating point values are used in DDA algorithm, but in Bresenham algorithm we are using integer values, so that we can easily draw the line. Okay, we can use line segment like a 1.1. See, if we want to draw a line, they are taking only integer point values, that is not decimal values in Bresenham algorithms. But DDA algorithm, they are using floating point values also. Okay, here. Of course, then we can check the statements what are all given. Option A is it avoid a round of operation. That is what I already told in the characteristics of Bresenham algorithm, and it is incremental also, and it uses only integer arithmetic. These three are the basic characteristics of Bresenham algorithm. So, but option D, this is wrong. This is not related to Bresenham algorithm. So that we can assume that which one is true. Option D. Here we can see that A, B, and C. These are all the. This is option for this question. The answer is option D. Okay. I hope this is clear. Move into next question. Next question. Given below are two statements. Statement 1, the maximum number of sides that a triangle might have when clipped to a rectangular viewport is 6. Statement 2 is, in 3D graphics, the perspective transformation is non-linear in set. This question is also from computer graphics. What they are telling, statement 1 is, if we want to clip a triangle, we want to clip a triangle into a rectangular viewport. Okay, we want to clip this rectangle into this triangle. How many how many sides it will be it we will get. That is what they are telling, 6 sides, but we have to check how many sides we have to get. We will check. Okay, see this picture, you can see I have clipped this triangle into rectangle. How many sides we will get? Total 7 sides. 1, 2, 3, 4, 5, 6 sides we will get. Is it? So the first statement is actually wrong. We will get 7 sides. Okay. Then second statement, what they are mentioned in 3D graphic, the perspective transformation is non-linear in Z. Non-linear in Z means uh, if we are drawing a picture in first I will give the explanation of perspective transformation. That is, in perspective transformation means if you want to draw a 3D object into a 2D platform, so that how the picture will look like. When we are seeing a far away object, we will draw like a small, in this, if we are drawing something, that is, one bird is flying here, and or hill is there, and one river is flowing, that is nearby object we will draw like a bigger, and the small, the far away object we will draw like a small picture, like how it will draw. We can draw like small bird is flying here. You, sorry, I couldn't able to draw, but you just imagine if you want to draw a picture like one hill is there, one river is flowing, and one bird is flying. We will draw that bird like a small object, that is bird is far away from our side, so we, that far away object we are drawing like a small. That is what, how we are transforming 3D object into a 2D flat platform. In that case, we are using, we are not using set coordinate. Actually, we just use what, this is x coordinate and this is y coordinate. We need only x and y coordinate. Those values are linear, but set, we there is no need to draw a set coordinate. If we draw, there is no need to draw a set coordinate to draw a picture. This is set values are non-linear. That is set if we are consuming this is set, this values are non-linear. Linear means what? The linear means we are 1, 2, 3 digits, that values. Okay, 1, 2, 1, 2, those kind of values are, we call it as linear values. But set values are non-linear. We have to find by, we will get some point or raster like values we will get, and not linear values we will get. That is what second statement saying. So these two statements are true as per, 3D graphics and 2D graphics. These two statements given are true. Okay. Next, sorry, sorry, but the statement one we will, that is false, and the statement two is true. Okay, sorry for that. Statement one is false. What we will get, seven sides we will get, but statement two is true. Z is non-linear. Okay, I hope you all clear with this statement. Next question is from, that is hardware control unit and microprogrammed control unit. We have learned in my, that is in microprocessor. This is microprocessor or computer organization, that architecture based question. This question is from computer architecture. Statement one is hardware control unit can be optimized to produce fast mode of operation. That is, a hardware control unit can be optimized to produce fast mode of operation. is this statement is true. We have to check that. Second statement is indirect addressing mode needs two memory references to fetch the operand. Okay, we should know what is hardware control unit and what is indirect addressing mode. Okay, let's look into the statements. The here what they mentioned, the control signal are provided by hardware circuit in hardware control techniques. The speed of hardware control unit can be optimized. We can optimize the speed of hardware control unit. And also, what I will give a detailed explanation about hardware control unit first. Okay, this is a pictorial representation of hardware control unit. Here you can see that how the control signals are generating. They with the help of these all the instructions are they are accepting, that is control signal generator is accepting all the instructions given from different sources, and according to that only they are producing control signals. First look into what are the components in hardware control unit. Here you can see instruction register, instruction decoder, step counter, external input, conditional signals, and here one control signal generator. We will let's look into each and every components in hardware control unit. Okay, hardware control unit means the instruction register is used to generate the opcode bits respective of the operation as well as the addressing mode of operands. That is what is the purpose of instruction register, that it can it is used to generate the opcode bits. Okay, opcode bits are generated by the instruction register. Okay, next is instruction decoder. The above generated opcode bits are received in the field of an instruction decoder. Already instruction register produced the opcode bit. That opcode bit who will receive? That instruction decoder will receive the opcode bits. Then the instruction decoder interpret the operation and instructions addressing mode. Now on the basis of the addressing mode of instruction and operation which exist in the instruction register, the instruction decoder set the corresponding instruction signal INS1 INSI to 1. That is, first look into the picture here. Here, instruction register what is doing? Opcode bits generating. Is it? Opcode bit is generating. Then instruction that opcode bit is received by instruction decoder. This instruction decoder will interpret the what is opcode bit, what kind of bits are given. Like that they will interpret, and as per that each instruction is executed. Each instruction is set to 1. If you want to execute first instruction, that will set to 1. Then instruction 2 up to instruction and they will set to 1 by 1, not all together, 1 by 1 it will set to 1. That is what mentioned here. Okay, next, step counter. Here you can see a step counter here. See, uh, totally we have that steps. First we learned the basic steps uh, in a hardware control unit. Each instruction that we have mentioned, different many instructions are there. Each and every instruction is following these operations. That is instructions of fetch, decode, operand fetch, arithmetic and logic unit, and memory store. Okay, these are the functions. These are the steps are performing by each and every instructions. Okay, so these 5 steps, as per which step is performing now, how we can know that? We can know with the help of step counter. Here T1, T2, T5. So T1 represent operation that is opcode fetch and decoding. That different 5 steps will we can identify through this step counter. Next is external input. You can see an external input here. See this external input. This is actually an interrupt. That is the this external input will help the control signal generator that one of the interrupt is coming. So you have to stop the at present working and do that, solve that interrupt. Like that they will, we can identify through this external input. It is used to tell the control signal generator about the interrupt which will affect the execution of an instruction. On the basis of the input obtained by the conditional signal, step counter, external input and instruction register, the control signal will be generated with the help of control signal generator. See, already I have told that this control signals are generated based on these another components, that is instruction register, instruction decoder, step counter, external input, conditional signal. Based on these instructions only, this control signal generator is producing a control signal. Okay, this is the working of hardware control unit. And apart from that, we have to find out, we have to understood what is the difference between hardware control unit and microprogrammed control unit. With the help of hardware circuit, we can implement the hardware control unit. In other words, we can see that it is a circuitry approach. We know that hardware control unit is definitely a circuitry approach. So, but micro-programmed control unit, here I mentioned micro-programmed. The word programming, programmed means it should be definitely some instructions based. It is based on instructions. Implement the micro-programmed control unit. Okay, based on programming only we can implement micro-programmed control unit. And in the hardware control unit uses the logic circuit so that it can generate the control signal which are required for the processor. Here in hardware control unit, many logic circuits or logic gates are using for generating control signals. But in the case of microprogrammed control unit, they are using micro instructions to generate control signal. What they are using? Micro instructions. Okay. Next, in this control unit, that is hardware control unit, are going to be generated in the form of hardware. That's why it is very difficult to modify the hardware control unit. That is, this hardware control unit is also already, I told that it is a circuitry approach, so that in the form of hardware, it is generating. So it is difficult to modify the hardware. For example, you assume we in our houses we have um, a washing machine. Washing machine, its control signals we can't modify. Whatever they are already implemented, that functions only we can perform. Is it? So that we can't modify if we can't add another functions into that. So you remember that exam. But in microprogrammed control unit, it is very easy to modify the microprogrammed control unit because the modifications are going to be performed only at the instructions level. So that that is in instructions we can change easily. Microprogrammed control unit means we can change the computer programming we can change. Is it? So modifications are possible in microprogrammed control unit. Then in the form of logic gates, everything has to be realized in the hardware control unit. That's why this control unit is more costly as compared to the microprogrammed control unit. That is, hardware control unit is very costly. Why? Because means here we are using logic gates. So if we are using many logic gates, it will definitely will, it will be very expensive. So that hardware control unit is comparing with microprogrammed control unit, it is very expensive. But in microprogrammed control unit is less costly. Okay, then complex instruction cannot be handled by hardware control unit because when we design a circuit for this instruction, it will be complex. Okay, we can't use many complex instruction to the hardware control unit. This hardware control unit is performing a single particular task only, so that we can add only very few instructions to that. So we can't add more complex instruction to the hardware control unit. But in microprogrammed control unit, it will, it can handle very complex instructions also. But in hardware implementation, limited number of instructions are using, and microprogrammed control unit is able to generate control signals for many instructions. the hardware control unit is used in those types of computers that also use the RISC. That is where we are using hardware control unit. Which type of computers mainly using hardware control unit means reduced instruction set computers are using. That is RISC is using hardware control unit, but here CISC, complex instruction set computers, are using the microprogrammed control unit. Okay, I hope you all clear this, what is hardware control unit and microprogrammed control unit. The last point regarding the hardware control unit is that this hardware control unit is only generating what is the exact need for exact need. That kind of signal only generating the hardware control unit, and it is very fast because only a very particular signals are generating, so it is very fast. But comparing with but micro instructions are used to generate control signals. The very many control signals want to generate, so it is very slow comparing with the hardware. Microprogramming more programmed instructions are very slow, but hardware control unit signals are very fast. Okay, I hope you all clear with this hardware control unit and microprogrammed control unit. So, the what is our statement? Control signals statement is what? In the hardware control unit can be optimized to produce fast mode of operation. So this is true, is it? This is true actually. And statement 2, indirect addressing mode needs two memory references. We can see what is indirect addressing mode. Indirect addressing mode means we have to access the main memory by two times. Two fetches are needed. Indirect addressing mode, two memory references to fetch the operand, as the address of the operand is not given in instructions, but the address field contain the address where the address of the operand is stored. Okay, here in this picture, here one opcode and here is the one instructions given. This address is referencing only the effective address that is stored in memory. And when we reach the effective address, there only they are storing the actual address of operand. So here two memory reference is needed. That is what indirect addressing mode. Okay, so in this question, these both statements are true. I hope this is clear. Moving to next question. Next question is, assuming that the system called fork never fails, consider the following C programs, P1 and P2 executed on Unix. This is a fork system call. In operating system or the Unix system, we have learned about fork. I hope you all know what is fork system call. Or else I will give a, brief idea about fork system call first. That is, fork system call is used to create a child process. So what is the function of fork system call? Used to create a child process. N number of successive fork call create 2 raised to n minus 1. This is actually 2 raised to n, not 2n, 2 raised to n. Okay, minus 1 child processes. Okay, fork system call is what is the purpose of main, what is the main purpose of system call? If one fork call is called, this will also generate uh, one child. Its child already, it's all one child will create. Okay, one fork call, we will totally two processes are generating. Hmm? Uh, so let's move into the question, what they are mentioning. Statement 1, P1 display happy 8 times. Statement 2, P2 display happy 12 times. We will check. Here, total 3 fork calls you can see. Okay, so one fork call will generate two process, totally two process. That is one child and one parent. Is it one parent and its child? Is it? So total 3 we have. So we know the formula 2 raised to 2 raised to n. Is it 2 raised to n is the equation total number of process we creating. So here total number of fork call is 3. So 2 raised to 3 means how much we will get? 2 raised to 3 wow, equal to what? Answer is 8. Is it? 8 we will get. So first statement is true. That what they are saying. P1 display happy 8 times. But in the case of statement 2, P2 display happy 12 times. We can see here one fork and again one print statement. Here one fork, here one print statement, fork, print statement. So first fork will generate one one parent and one child. Is it one child? But in the case of second and print happy. So here 2 times happy will print. Is it? 2 times happy will print here. And next for call, what will happen? Here one fork is there. So next fork again one here one parent and its child and its child and also these two already created processes will generate one child. Is it? One child will create here. So totally in the second step total how many times will print the happy? 4 times here print 4. 4 times happy will print 4 times. Is it? 2, 4. Next fork code. Again, here is one fork. Is it? One fork. In this fork code, again, totally mainly 2. Mainly 2. Apart from that, mainly 2. Okay. Apart from that, these two will generate this child is from this parent and this is from this this is two these two child from this fork code. This is from this fork, this process, and this one also create this. Okay, and this 4 will generate again 2 2 again 1 1 4 again will we get here 4 1 2 3 4 also will generate 1 1 child. So again 1 2 3 and 4. So totally how many process you are getting? 1 2 3 4. Is it? 4 plus 3 plus 4 plus 3 7 7 plus 2 9. Totally actually 14 times 8 8. Here totally how many? 4. Here actually 2. This not needed. 4 plus 4 8 here. Is it? 8. Correct. 8. So 8 plus 4 plus 2, how much you will get? 14. That is the third step. the main for call is calling, two will generate, and apart from that already generated processes will generate each child. So first two process will generate two process. This 4 will generate again 4. So 4 plus 2 plus 2. How much will get? Here 8. Third step 8. So 8 plus 4 plus 2, 14 we will get the answer. Okay, 14. 14 is the answer. I hope this question is also clear. 14, total 14 times happy will print. So statement 2 is wrong. Here 14 is the answer. Statement 1 is true and statement 2 is false. Okay. Next question. Given below are two statements. Quality control involves the series of inspection, reviews, and tests used throughout the software process to ensure each work product meets the requirement placed upon it. This question is from software engineering. And statement 2 is quality assurance consists of auditing and reporting functions of management. This is what actually they have given the definitions of what is quality control and the quality assurance. Those who are very clear about this definition of these two terms, they could easily identify the answer. Let's check into the definition of quality control. Quality control is a series of inspections, reviews, and tests conducted during the software development process to ensure that each work product follow the specification. So statement 1 is correct. That is control quality controls mean it's a series of steps conducted during the software development process. But in the quality assurance, management, auditing, and monitoring activities make up quality assurance. The aim of quality assurance is to provide management with the information they need to make informed decisions about product quality. Okay, it is regarding management, they are doing auditing and monitoring activities. That is what quality assurance. Okay, these are the main difference between quality control and quality assurance. Quality control is mainly focusing on product oriented, but quality assurance process oriented. So, because quality control means the product, how it should work, that kind of activities they are focusing. But quality assurance, the process that is related to process oriented. Here, the goal of quality control is to identify and fix defects. Identify and fix defects. And quality assurance is prevent the defects. Okay. Here, identify, it will, the job of quality control team is to identify and fix defects, but quality assurance will make sure that there is no defects will not come. It will preventing actually. Activities, what are the activities following in the control quality control system means testing, inspections, reviews are uh, conducted in quality control, but in quality assurance, auditing, process definition, training, documentation are doing in quality assurance. When is performing this quality control? During and after production. This is each and every production they are using uh, this quality control is performing. But quality assurance is doing before and during production. Here after production. Here during production. Okay. Responsibility often performed by testers, developers, and a QC team. Who is doing this quality control? Actually, they are done by testers, developers, and quality control teams. But in quality assurance is developed by doing by done by the quality assurance team and management. Here, the question is asked by the team: is the product right? Product is right or not? That is what asking in the quality control. But in quality assurance, they are asking: are we building the product right? That kind of question is actually making. Are we building the product right? Okay. Uh, I hope this will clear for you. And the question is what? These definition they have given quality control and quality assurance. Based on this statement, we can conclude that these two statements are true. Okay. So statement 2 is correct and statement 1 is correct. I hope this class is very useful for you. We'll see